Okay, welcome everybody. I don't care if you eat lunch, that's fine. Move around, go to the bathroom. The only thing is don't make noise for the people in the room who are trying to listen. And also let me tell you that I'm going to have a few strange pauses in here. It's to assist in the editing of what I'm saying when it gets posted. It'll be posted on my website and on YouTube. Also, there are two videos, and I'll announce them when I get to them. I have perfect permission to show them to you here, but I do not have permission to post them. So they will have to be edited out of both my version and whatever recordings you guys make. So, welcome to a wrap-up of NAB 2015, and the theme of NAB 2015, this is not my theme, it's NAB's theme, was Crave More, with this mindless creature that's just trying to crave more of everything. And I will talk a little bit more about the mindlessness in a moment. My theme of NAB 2015 is Crave More Respect. And wouldn't it be nice if we could do that? So, what do I mean? Well, first, how about some respect for fairness? There are lots of awards that are given out at NAB, and they are now pay-to-be-nominated awards. So when you see, oh, this thing has won so-and-so's best award for NAB, well, they paid. How about women? I happen to have a notion that women are people, and like other people, they tend to wear clothes, they come in all sizes and shapes and so on, but Atomos doesn't. As far as Atomos is concerned, women are objects. And so they had a return of topless models at the Atomos booth, supposedly to attract crowds. And here is a picture of the Atomos booth showing that, fortunately, NAB showgoers are not so stupid that they will come to a booth only because there are topless women there. How about some respect for intelligence? Here is a demo that happened. Now, I've blanked out the name of the company's demo because anybody can have problems, last-minute demos for NAB. But when you have a problem, it's traditional to say something like, well, we couldn't quite get it working for the show, so please bear with us. Instead, they just went through the demo as though there were nothing wrong. And so here's a demo of a virtual set. Anyone see any problem in this demo of the virtual set? Now, there were some non-lives at the show that were still interesting. So here is a company that was offering live sounding weather. Not live weather, but live sounding weather. And then there were outright lies. And here's a very popular one that was at many booths at the show, zero latency. Many booths talking about zero latency. So here is a video. We'll see if this runs. Okay, what you are seeing there is a single pulse of light going through a Coke bottle. It was shot by a camera that has a frame rate of 1 trillion frames per second, and it has been slowed down by a factor of 10 billion to 1 for what you're seeing here. Well, if light has latency, then there ain't any such thing as zero latency. So nothing has zero latency. By the way, I didn't point out on that last slide, there are 2 Japanese universities who have now gone up to 4.4 trillion frames per second. So even in the range of 1 trillion frames per second, we can talk about advancing to HFR. So what was zero latency at NAB? Well, I'd ask people, okay, you're saying it's zero latency. Really, what is the latency? And when they would finally answer me, one of them said, oh, around 90 milliseconds. Well, if you're doing a prompter, that's not bad. That's no big deal. It's 9/100ths of a second. It's not going to throw anyone off in reading a prompter, but not so good for certain other purposes. Here is something taken from a brochure of a camera that was introduced at the show. And it says that the new optical system supports the wide color gamut of ITU-R BT 2020, enabling more precise color reproduction in live broadcasts. And this is true. Here's a diagram from Extron's website. There's ITU 709, the HD color gamut, and there's BT 2020, which covers a tremendous amount more range of the color gamut. But notice that after BT 2020, there's not only an asterisk, but a 1. So let's take a look at what the footnote says. ITU-R BT 2020 is the specification of video format defined by ITU-R. The camera does not cover it in full. Okay, how much of it does it cover? We're not going to tell you that. Then there's one side only stuff. Now, this I normally have to explain very well, but this morning there was wonderful stuff on IP, so I don't have to do much explanation. IP is wonderful because it allows you to use commodity components. So here's a 1 gigabit Ethernet router for 25 bucks, including free shipping. Of course, that's if your plant is already IP. But if your plant isn't, you may want to go back and forth between HDSDI and IP. This is a device that Extron had at the show. I don't know how much it costs. I tried to find out, but I found out that the replacement power supply for it is 250 bucks. IP is wonderful because you don't need any central router. On the other hand, there are differences of opinion. So there's the Evertz 46 terabit per second router that I spoke of last year. IP is wonderful because it helps remote the remote. That's one of the things, again, that people were talking about this morning for sports stuff. Here is a diagram of a particular remote production truck. This happens to be All Mobile Video's Titan. Now, let's say that we use super advanced technology and we were able to reduce all of the electronics on this truck to a single chip. What would happen to the size of the truck? This is what it would be. Because we have all those people, and all those people need monitoring, and all those people need control surfaces, and all those people are generating heat, and so they need air conditioning. So it's basically the same size truck. Maybe it would weigh a little less. So it's nice, however, to not ship people around. On site, you have to have audio assistants, you have to have video utilities, maintenance engineer, stage managers, maybe talent. But is this trip really necessary? Graphics people were some of the first not to go, recording and playback, the director, AD, TD, the audio mixer, and even the camera operators. You know, why not have remote-controlled cameras? So here was a super session on IP that NAB had, and everyone on that stage is a big fan of IP, and they were telling everyone, it's ready now. We've built the facilities, we're offering the products, you give us the check, you get your IP facility. But the moderator, Deborah McAdams of TV Technology, elicited some comments from the audience that were not necessarily so rosy, and one person said, well, gee, if even in the IP world, people have different standards for routers. Are we really ready to do all this stuff in video? And you had a lot about that this morning, so I'm not going to give you any more. A little bit more on respect, superlatives. NAB 2015 was brought to you by World's First Corporation. So here is an announcement that's appeared in the press after NAB. I've trimmed off which company it is, but it says so-and-so has announced the world's first handheld 8K UHD camera system. That wasn't the only world's first. So there's this small problem that this, as you can see, came out at NAB 2013, and it's a handheld 8K camera. I don't know if that was the first. They're not claiming it. Countryman, by the way, continues to show that their very nice microphone was used in this production of South Pacific, which was live from Lincoln Center in 2010 and has not yet been credited by Countryman. How about instant change? Well, here's a little thing at the JVC booth. Obviously, on this projector, I can't show you high dynamic range, but you can see kind of the shininess in the water on the high dynamic range version, and I can tell you that it really had impact. So JVC had the camera, they had the display, we're ready to go, high dynamic range tomorrow. Well, here's a picture some of you may have seen, maybe not. This is an image in a lab, and the only light in this room is coming from the lamp that's pointed right into the lens. And yet, some of you may be able to see that every single black chip on the chip chart is visible. All the white chips are visible. There's tremendous dynamic range in this picture. In fact, it's got a contrast ratio of 10 million to 1, or more than 23 stops. It was shown at NAB in 2008 by Grass Valley. It's from their Sensium sensor. They have yet to issue a camera that offers this dynamic range. There is, however, another company that, using the same sensor, does offer the dynamic range in their camera, and that's Lux Media Plan. I really love that thing down at the bottom right. I've blown up a little bit of the lamp for you. You can see every coil of the tungsten filament, and yet still see every chip on the chip chart. And then there was just utter nonsense. So here we have a snow shield for a dish. Probably familiar with that, except this snow shield, as you can see, is an Ultra HD snow shield. And then here's a company, and they're offering they're offering 4K filters for film. So this is great. You know, you're using a diffusion filter or something, you want it to be 4K. But I also like their subhead. It's a breakthrough in optical HD glass. So what is Ultra HD? Well, people these days say it's got something to do with high dynamic range, wider color gamut, higher frame rate, more immersive sound, and of course, higher resolution. The term Ultra HD originally meant 4 times HD resolution in both the horizontal and vertical directions, which today we call 8K, and then some people are calling things 4K. You may recall in 2010, the elephant in the room was stereoscopic 3D. The elephant in the room at this year's NAB was 4K. So why 4K? This is sort of a triple entendre. Do I mean that this is the year of 4K, or do I mean that 4K will be available in the year 4000? Or do I mean, why should we have 4K? Well, I sort of mean that. There are 2 main reasons. One is better pictures, and the other is an ability to zoom in by a factor of 2 to 1 for HD, so shoot 4K for HD. Here is an 8K screen that was shown at NAB by Astro. They call it the world's smallest 8K display. It's a 55-inch, and 8K just sucks you up to the display. So up close, this was amazing. I spent, 20 minutes staring at this screen from 2 inches away and looking at the phenomenal detail that was in it. But when I first passed by the booth and glanced up, it was, okay, it's an HD screen. And if it didn't say this is 8K, I wouldn't have known it was 8K. This is typical 8K viewing. And I'm serious. There's nothing wrong with this. This could be terrific. You're a doctor, you want to look at x-rays, you want to see the detail, great. Look from 2 inches away. Or there's a point of sale display. An 8K display just sucks you right in. Or it's some kind of a theatrical thing where you walk right past it. This is all great. But 8K is not something that you really appreciate at home viewing distances. So here's Ikegami's booth, and the thing on the right was a 4K display, 293 inches in diagonal, so it's 12 feet high. Probably not going to fit in the home, but even that display, not a lot of people were looking at. So there have been viewing tests, and here are some, 4K viewing tests that were done by the European Broadcasting Union. Other people have done the viewing tests. They come up with about the same results. So the red line is how much improvement there is at typical home viewing distance, 2.7 meters or 9 feet. The black line is how much improvement there is at a distance from the screen of 1.5 times the picture height, which for a 56-inch screen is about 40 inches away. And there is a statistically significant improvement from any form of HD to 4K. The distance from the top is how much improvement you're getting. So at 1.5 times the viewing height, the improvement's about a half a grade, and at TV viewing distances, it's about a third of a grade. statistically significant, the pictures are better. But if you increase the frame rate, every doubling of frame rate is a full grade of improvement. This requires 16 times the data rate per grade of improvement. This requires 2 times the data rate per grade of improvement. And over here we have high dynamic range, and going from 100 nits to 400 nits is a grade of improvement. Going from 400 to 1,000, close to another grade, and then 1,000 to 4,000, close to another grade. Now that can be as little as 0 times the data rate. If you want to use a few extra bits, maybe 20% increase. So you get a lot more bang for the buck for data rate out of dynamic range or frame rate than you do out of increasing the resolution. Then there's this question of, okay, well, how about shooting 4K 4HD because you can get another 2-to-1 zoom in. So here's a HD picture, and let's say you wanted to see, oh, is this guy tripping this guy? So we can divide that into 4 quadrants, and if we shot this in 4K, then we can say, okay, going across was 3840 by 2160, and over here it's just 1920 by 1080, so we have a 2-to-1 zoom factor. And if all we were talking about were pixels or sensors, that would be absolutely true. But there's another element in there, and that's the lens. And here is the modulation transfer function, or how much contrast gets through a lens for a very, very high-end HD lens. This is an extremely expensive HD lens. And you can see 100 line pairs per millimeter is HD, and in the center for HD, you're getting, what, about 75% contrast coming through. Not bad, pretty darn good. But 200 line pairs per millimeter would be 3840 resolution. And there, even in the center, we're down to 52% contrast, considerably worse. And the sharpness of a picture is proportional to either the area or the square of the area under the curve. It depends which school of thought you have. RCA and Sony say it's the square of the area. I tend to go with that one too. Zeiss and Ari say it's the area. But either way, the area is diminishing down here. Now, here's a bit of a press release that came out for something at NAB this year, and they're talking about an 8K camera here, and they say with the system expander, you can stick one of those HD lenses on your 8K camera. So I leave you to do the extrapolation of these curves out to 8K, which is over here. And that's 7840 8K, or 7680 8K. And if you went to 8192 8K, it would be 427, so a little bit farther to the right. So here's a common HD field camera lens combination. And the interface between the lens and the camera is extremely well defined by a standard called BTA S1005A. I think they're up to 1005B or C at this point. And it defines not only the mechanical mount, which is called the B4 mount, but also the color depths, which are different. So red and blue are both farther behind where green's color depth is. So if this is what's inside the camera, I'm just looking at 4 pixels. This isn't a 2x2 camera. It's 1920 by 1080. If you have a 2/3 inch sensor, then each photo site is 5 micrometers by 5 micrometers, which is kind of what you need because light has noise. So even if you eliminate all the noise from the camera and the processing, there's still noise in the light itself, and it has to be integrated in the photo sensor. So let's say you want to go to 4K. Well, the obvious thing is, okay, let's just scale this up. And that's what Lockheed Martin did in 2000. They went to a big prism with big CCDs, and it was essentially an HD camera except size large, but size very large. This is not something you're going to stick on your shoulder. So other people came up with a different option, and that was to go to a single chip. And the single chip is super 35 millimeter size, which happens to scale up perfectly, so you still have 5 micron by 5 micron sensors. But there are a number of problems by putting this color filter on top. One of them is the red, if this is a 4K chip, the red has only 2K resolution. The blue has only 2K resolution. The green has 4K resolution horizontally and vertically, but not diagonally. It's what we call a quincux panel. And so a problem with that is you cannot do a perfect optical low-pass filter. If you filter for the red or the blue, then you're losing resolution in the green. And if you filter for the green, then you're letting aliases through in the red and the blue. Another is up conversion is necessary. If you've got 2K red and blue and you want to output 4K, you got to have up conversion. And if the chip is just 3840 or even 4096 across, then it's not delivering 4K because of the color filtering. Now, some people have a lot more resolution in the chip than 3840 or 4096. So this was the side of Red's booth at NAB, and it has a quote from Jim Gennard in 2006, "Up-resing not spoken here." And that reminds me of the debate over what's happening in Florida, whether it's illegal to use the term climate change there. Doesn't mean climate change isn't happening, it just means you're not allowed to say it. So same thing with the camera. You may not be able to say up-resing, but it's got to do it. So there's upscaling, up-conversion, debayering, demosaicing, whatever you want to call it, there is up-resing happening. There's also lens considerations. If this was a lens, the red circle for that HD camera that I showed, and you try to use that lens on this bigger camera, then you've got a problem. The lenses are PL mount. They're primarily prime lenses, which are not zoom lenses. The large format tends to mean a much narrower depth of field, all else being equal. And if you use an adapter from a 2/3 inch lens, let's say you want to stick on one of those long field lenses to a Super 35 sensor, if that adapter is absolutely optically perfect, it's going to lose 2.6 stops of light, or roughly 600%. So you need 600% more light. And again, as I pointed out before, the modulation transfer function of the lens is HD, not 4K. So here's a different option, and this is what Panasonic introduced at the show in the AKUC 3000. They said, okay, we're going to build a camera that will take 2/3 inch lenses. We're going to put in a 1-inch format sensor, which is halfway between the 35 millimeter format and the 2/3 format. So your reduction is just a 16 to 11 reduction. You have much less loss than the 2.6 stops. And because they're putting the optical adapter inside the camera, it allows you to use the range of lens correction systems that the high-end camera manufacturers have been using to correct for chromatic aberration. Another option is, oh, let's just shrink the pixels. So this is what Ikegami and Sony showed at NAB this year, 2/3 inch sensors, but truly 4K sensors. There are 3 CMOSs. These are the first 4K, true 4K cameras since the Lockheed Martin in 2000. So there is no up conversion involved in this. But because it's a 2/3 inch sensor, we're no longer 5 by 5 microns, we're now 2.5 by 2.5 microns. And so sensitivity and noise is an issue because light has noise. And so if you look at the specs of those cameras, they have lower sensitivity or more noise, depending on how you want to look at it, than other cameras. And then here's what Hitachi introduced first at IBC last year, but this was its first NAB, 4 HD sensors. All 4 of them are purely HD sensors, but there are 2 greens, and the greens are offset by 1/2 pixel diagonally, and so they're creating a 4K resolution. You need an extra prism element to split the light, and you do Bayer-like processing on it. So that's Hitachi's version. But all 5, one more coming up. So that was 4 companies. And here's the 5th one, Grass Valley in their LDX 86. The lens is 2/3 inch HD. The optical block, the prism, the optical filtering is 2/3 inch HD. And the sensors are 2/3 inch HD. So it's an HD camera. But it's got up conversion afterwards. And so you go, It's an HD camera, it's not a 4K camera. But because everything matches, the optics match the sensors, everything matches perfectly, you can do a better up conversion on this camera than you can on a camera where things don't match. And so Grass has been comparing their 4K pictures to the 4K pictures coming out of other cameras. So now we have 5 companies, Grass Valley, Hitachi, Ikegami, Panasonic, and Sony, basically the 5 manufacturers of field cameras, all with 2/3 inch 4K cameras. Well, when that happens, the lens manufacturers take note. And so Canon introduced what it called a prototype 4K long zoom, and Fujinon introduced these 2 products, 22x8, almost identical to what they'd have in HD in terms of range, and an 80x9 for their field camera. And if we look at the MTF comparison of those 4K lenses versus the HD lenses, you can see that in the 4K range, they're doing an awful lot better than the HD range. But let's take a look just at the HD range, that 100 line pairs per millimeter. You get, 90-something percent contrast out of sticking that 4K lens on an HD camera. That's terrific. I'm really looking forward to use those lenses. I have no interest in 4K, but this is one heck of a lens to put on a HD camera. Essentially any lens is going to pass any spatial resolution. But the question is, what is the MTF? And the MTF on this lens is terrific. It's also got less reflection, so it's got more transmission. So it's a more sensitive lens. You need less light with this lens than you need with the HD lenses. And it's got shifted peak performance, which I like a lot. Some of you may not be as appreciative. For today's HD zoom lenses, they're limited at narrow apertures by diffraction, and they're limited at open apertures by the sidal aberrations. And so there's some point where those curves cross, and that's where the peak performance of the lens is. So for today's HD zoom lenses, that's around f4. For this lens, the peak performance is around f1.8. So at the extreme open end of the lens. That's great if you're shooting a dark opera. So I love it. Another sensor that was introduced at NAB, this was at Red's booth. By the way, I said I would say which booth I thought was the worst. That's Atomos because of what they're doing to women. But some people say Red's booth was just as bad, maybe worse. Somebody compared it to the Holocaust with bones lying around and so on. But they came out with an 8K sensor, the Dragon sensor, and it's got a 46.3 millimeter diagonal. That's about twice what the Super 35 sensors have. So they say, well, you can use the lenses that you use for full-frame 35 still cameras. Well, that's a full-frame 35 still, and it's got 43.3 millimeter diagonal. Now, it's probable that the lens will cover a little bit more range than that, but if it doesn't, those little red ears that I'm showing there are going to vignette because they're outside the range of what the lens will cover. This was another camera. This was shown at the 4A booth. It's a Flovell camera, the HBC 3600. It looks like a nice daytime scene until you look at what it's really shooting, and it's at night, so very sensitive. Here are some other camera-related things. This was nice. Small HD had a thing called a side finder. This is something about the size of an iPhone. And then they made this little mirrored thing, and so you can slap that on and use it as an eyepiece viewfinder or open it up and use it as another viewfinder. And this I just thought was really cool. It's an autofocus 20:1 HD camera module about the size of my thumb. Some more acquisition. This is BBS pipeline. Looks kind of like fluorescent tube light fixture, except it's not. They're LEDs that are exciting phosphors. And you get a much broader range spectrum out of that. For those of you who thought that the Segway was too big, there's a one-wheel version, and there's a little tiny version. This was an interesting thing from a company called Andra. This woman is wearing a sensor on the back of her neck, and she was just popping around the booth and coming into the frame and out of the frame at different distances, and wherever she was bang on in focus because this thing is doing a little RF field and is measuring what's on her back. This was a cute thing from a company called Virtual Backgrounds. It's basically like a prompter, except instead of a prompter, there's a video projector over here that's going into the beam splitter. And so you can have whatever background you want, and it's like blue screen, except there's no blue screen. So you actually see in the viewfinder what the shot is going to be and whether you like it or not. And then this, probably the most important thing at the show, but there wasn't anything to see, and it's ACES, the Academy of Motion Picture Arts and Sciences color encoding standard, and it allows any combination of cameras to be brought to exactly the same color conditions so that you can intercut between the cameras. And if in post you decide, oh, everything should be darker, all the cameras get darker the same amount, or everything should be redder, all the cameras get redder the same amount. And that brings me to the Fraunhofer light field. They've been showing things for a long time. Their light field camera is a bunch of little cameras, and the spacing doesn't really matter so much. This they're putting into a beam splitter 3D rig. So this is a Sony high-end digital cinematography camera, and there's the Fraunhofer camera. They've previously shown that by doing this, you can refocus in post, pick what's in focus. You can reframe in post. You can re-iris in post or do high dynamic range. And at NAB 2015, because you know the depth of everything in the image based on these cameras, you can actually relight in post. And now I'm going to tell you that the next thing you're going to see is one of those videos that I have the rights to show you, but cannot be posted on the web. And so this is, what if you decide in post, gee, I wish I lit the back wall differently. So there's the scene, not seedy enough. I'll just make it darker. Let me go back and do that one more time for you. That's post-production relighting. And now, just to show you how crazy it can be, this next one is a spotlight that did not exist on the set that's flying around in post. And she just happened to blink. It had nothing to do with the light. So I'll show you that one again. Okay, another thing related to depth at NAB, this was at NTT's booth, and this is a system they call Kirari. Now what they're showing here is just a Pepper's Ghost, basically a beam splitter. There's a video image up here, but the tennis table exists in real life, and they're showing a theater with people cheering. But what they plan to do for the 2020 Olympics is actually, for various sports, transmit the athletes separately from the background. Rig up theaters that are like what the backgrounds are of the people performing, stick the athletes in there, and then you have this exciting sensation that they're calling Kirari. Here's another possibility. It's virtual reality goggles. There are problems with 3D looking at a screen at television viewing distances because of the separation of vergence, what our eyes point at, and accommodation, what our eyes focus on. That goes away if you have virtual reality. On the other hand, can these three people be said to be watching the same thing together? And here's Google's version. And the reason for that is you take your smartphone and you stick it in there and fold it up, and suddenly you've got a virtual reality system. Here was a display at NAB. It's an LED display. A lot of people have had this kind of thing before. This is a Chinese company, Unilumin. But what excited me more is this little display over here, and that's because it has a 0.8 millimeter dot pitch. This has 1.6 millimeters. There's a few other companies that offer 1.6. 0.8, we're starting to talk TV screen pixel pitch. And so you can have that behind your talent and zoom in for a close-up on your talent, and you don't have any problem with the screen behind them. That's pretty exciting. This was outside. This is at noon in Las Vegas. You can see from the chair here, the shadow is coming pretty much straight down. And that is a color picture out in the Las Vegas bright sunshine. And they had several other sizes. And this is from the HPA Tech Retreat in February. That's Jan Fröhlich of Dolby, and he's showing some BT 2020 color range. The reds in here, you can't really tell on this projector, but they're far beyond what you normally see. And that was coming from a Christie 3P projector, and that was at NAB. It's got very high output. It's got no speckle or scintillation because it's got so many different laser sources, high dynamic range, and almost entirely full BT 2020. The blue is maybe not quite on the dot, but very, very close. JVC had this from Silvus Technologies, a kind of mesh network for getting your videos back. You've heard a lot about that here, so I won't go into it. Film is not dead at NAB. And this is one of my favorites at IBM's booth, Experiences made with IBM. And Experiences appear to be a young couch potato holding a remote control. So that concludes my comments about NAB, but now I will show you something that was not at NAB, but it was at IBC. This is a company called Bado, and it's kind of next stage citizen journalism. It's a way of coordinating everyone out there. It's like suddenly, doing a contest. Okay, who's near this news event? Can you get the footage? Can you get it back to me? I don't know why they weren't at NAB, but they've got some great customers. And that gives us the intro to the next presentation. Where did the newscast come from? And the simple answer is 19th century French science fiction. Two great books, Le Monde tel qu'il sera, which is The World as It Shall Be by Émile Souvestre in 1846, and Le XXe siècle, which is the 20th century by Albert Robida in 1882. So, is this the 35th anniversary of the 24-hour news cycle? CNN started in 1980. No, it's the 169th anniversary of the 24-hour news cycle. And that's in Souvestre's book. Now, they didn't even have very much telegraph at the time, let alone telephone or any other technology. So his 24-hour news cycle technology is a newspaper. And the newspaper runs on rollers. And it goes throughout town, and if you're not a subscriber, then you try to read it as it zips past. But if you are a subscriber, there are enough spring-loaded rollers in your home that you can read things at your leisure as they go by, but still to see the articles that you want. They're coded according to whatever your political preference is. And by the way, as is the case with many science fiction innovations, it followed closely on a real-world invention, and that was the invention of continuous roll wood pulp in 1844. Here's an audio newscast in 1882 in the 20th century, chapter 3, and this woman is awakened by the newscast. Verbana, 11 p.m. His Majesty the King of Senegambia was assassinated minutes ago. Dynamite bombs and electric torpedoes were launched into the palace. They also have the television news, and what I really like about this one, it's the same book, and it's high definition. Look at the aspect ratio, it's 16:9. Injured correspondents become the story, just as they do today. But a difference is libel complaints are settled by duels. And there's the Bloommobile of 1882. It's covering desert warfare, handheld camera, one-person crew. There's clear press marking there, so that indicates non-combatant status. But of course, you do need very long cords for the camera and the microphone. The source of the idea, again, science fiction things are based on actual things that happened. It was in 1881. This is a picture that appeared in the graphic. This is at the First International Electricity Congress in Paris, and they were sending plays and operas to the Electricity Congress over telephone lines, and they were doing it in stereo, so people were listening with hands up on both ears. And Robida was definitely influenced by that. The first actual newscast, 1893 in Budapest, Hungary. And the guy who actually worked on this 1881 system, one of the guys, Tivadar Puskás, he designed a system for Budapest. He died just before it went into operation. And they hired 6 people called stentors to read into telephone wires, but they were a full news operation, editors, news desks, and so on. And then they would play music when the news wasn't happening. The first television newscast, 1928, regularly scheduled television newscasts by Colin Hager over WGY in Schenectady, New York. And that's him posing with a bunch of the microphones used from various dates. But even 1928, there were much older live remote visual sportscasts. So how did that happen? Here's a guy, Bob Lemon, when he was inducted into the Baseball Hall of Fame in 1976 as part of his speech. So he was born in September, and that was 1920. And my mother had to see the World Series at the old Opera House in Redlands, California. And in those days, they didn't have baby sisters. They had clothes baskets. So they put old Lem in a clothes basket, and they went to see the World Series. I was probably about 6 weeks old. So how did they watch the World Series in 1920? Well, in fact, as far back as 1884, people would go to theaters to experience live remote baseball games. There were 3 telegraph operators. One of them would telegraph the plays, another one would announce what the plays were at the theater, and the third one would move some visual element around. Initially, it was flags on a board indicating the players. But then it started getting more complex. So in 1888, it was pins. In 1889, the pins would move around, and you can see this guy's that far off the base, and this guy's farther off the base. 1891, electricity was added. Here's a newsreel clip, and this is just going to repeat over and over. It's only a 5-second clip. Oops, I guess it's not going to repeat. I'll play it over and over. But you can see the runners moving around, where the ball is going. Sorry? The reason that this clip exists, by the way, it was thrown out in a trash dump, but the trash dump was in the Yukon Territory where it was really cold. And so the Canadian Archives found it. It was in reasonable condition, and they restored it, and so now you can see it. By 1894, they started using androids. This was a system supposed to be able to be operated by one person. And you can see there's little light bulbs where the gloves are, and that's how you could tell where the ball was. The glove would light up if it was the one that had the ball. And here's a report in the Richmond, Virginia Times talking about, I declare they look positively handsome when he knocked that home run. And here's something from the Arizona Daily Star in Tucson saying, even in 1931, come to the Opera House to watch the World Series between the Phillies and St. Louis. So I think that covers me, and are there any questions? Yes, Eric.
There you go. 2 questions. One about what you were just showing. Do you have any sense of was that a viable business at all? Like how much money was put into developing all these different ways of doing remote baseball, and that people really watched it and it worked? I mean,
it was an extremely viable business into the 1930s. What killed it was not television, but radio, because radio finally got good enough. The first game to be broadcast on radio so that civilians could hear it was in 1921. And it was in Pittsburgh on KDKA, and the announcer was a guy by the name of Harold Arlen, L-I-N, not L-E-E-N, not the composer. And he announced the game the way he thought, which was when there was a pitch, he said, "What happened?" And then he shut up. And he later said, "Nobody told me I was supposed to talk between pitches." So the radio broadcast was extremely boring, but if you went to one of these theaters, by 1886, they had worked out the choreography of the sportscast. So maybe in 1884, they said, "And it's a good pitch, and he hits it." Well, by 1886, they were saying, "And it's a high fly, and it's out!" out to Dalrymple! And the Detroit Opera House erupts in applause. But yes, extremely lucrative. There were 44 US patents that were issued for a bunch of the display systems. And lawsuits over the patent rights would go as high as the Supreme Court.
And my other question goes back to the whole 4K camera thing. I mean, I detect some skepticism in some of the things that you're showing there, and I'm wondering, I mean, what do you really think is the deal with 4K or above? Are we trying to go beyond what the physics will really let us do, and therefore we should, I don't know, either stop doing it or be satisfied at some point?
I don't think it's a physics issue.
Really, lenses for 8K?
Well, as you can see, they've made a really good lens for 4K. They can apply electronic processing. We can maybe get rid of lens aberrations through processing, as we're doing now for chromatic aberration. Maybe we can get rid of other aberrations. Light field technology is another thing that can be applied. So, yeah, the physics is a challenge, but it's not a serious issue. The serious issue for me is the home viewing. Yes, there's an improvement. It's not a great improvement. Same thing at IBC 2013. There was a German company, Penguin Engineering Bureau, and they ran listening tests for multi-channel sound. And they did stereo, multi-channel, and then this very immersive system that they had. And what they found was between one-dimensional sound and super immersive sound, huge perceived improvement. Between one-dimensional sound and two-dimensional sound, a big improvement, but not as big as the previous one. Between two-dimensional sound and the immersive sound, the smallest improvement. So when you've got something that's already pretty good and you go beyond that, it's a little better, but is it enough better to give you what some people call a JVD, or a just valuable difference, something that's going to get a consumer to buy something? And I don't know how many of you ever get to New York, but if you do, when you're in New York, contact Bob Seidel at CBS, and he will arrange to take you into their lab where you can experience yourself what 4K into 4K, 2K into 2K, and 2K into 4K look like. And you can decide if the improvement is enough that you want to really work on it hard. But for other purposes, as I said, 8K for a doctor who's looking at an X-ray, fantastic. Love to do it. Other questions? Yes?
Do you think we'll
Peter.
see, since going from 4K to 8K probably doesn't make a whole lot of sense, do you think we'll see immersive video, the Oculus Rift, as another way of doing live television down the road, that people will start figuring out ways to actually not just use it for games, but actually content like live sports or something?
So the question is, if higher resolution isn't going to be the super big winner, do I foresee something like virtual reality, Oculus Rift headsets or something like that being used for live television? I can see it being used. The question, as Eric was asking about the sports systems, is there a market there? Can you get enough people to make it valuable? Maybe you can do some sort of up conversion from 2D to 3D that'll work in the Oculus Rift system. But it's a very different kind of thing. I like to deal with media in terms of their environments, not their technologies. So to me, the difference between cinema and television isn't that one's electronic and one is film. In the old days, it's that one is a room full of people who bought tickets and are watching a very large screen and have no distraction, and the other one is maybe a small group of people who are watching a smaller screen and there's light and there are distractions. So those are two different environments. The Oculus Rift is yet another environment. And maybe it'll be an environment that people will want to make stuff for. Any other questions? Yes?
I think you have a few minutes. Those of us who read your blog, there was a very interesting article in March about the bane of our existence, about who really invented television. Maybe you could share some of your digested version of that insight.
Well, no single person invented television. And there are people who think television started in 1939 at the New York World's Fair. That's fine, except that there was regularly scheduled television in Britain starting in 1936, even using cathode ray tubes. That's fine, except the first baseball game was televised in Tokyo in 1931. That's fine, except as I showed you, Colin Hager was doing television newscasts in Schenectady in 1928. That's fine, except John Logie Baird showed his first picture in 1925 of a recognizable human face. That's fine, except Science and Invention had on its cover a picture of a television set in 1922. That's fine, except Archibald Montgomery Lowe did a demonstration to the Society of Automotive Engineers in London in 1914. That's fine, except Alan Archibald Campbell Swinton came up with an all-electronic television system in Nature in 1908. That's fine, except the first picture tube was invented in 1907 by Boris Rosing. And you can keep going back. In 1879, the first live television picture appeared in Dublin. An ophthalmic surgeon by the name of Dennis Redmond introduced that. And you can go back a little bit before that. As far as 1877, there were 8 proposals for television systems. But before 1877, nothing. Nada. Zip, zilch, 0. So what happened to make those systems start coming out in January of 1877? Well, there's 2 things. And the first one, we go back even farther to the bane of our existence, Bain being B-A-I-N. It's Alexander Bain. And he was a Scottish clockmaker who came up with a bunch of telegraphic inventions. And one of them, he invented it in 1842, he patented it in 1843, was the ability to transmit images through scanning. And so, and the system works. In 1997, there's an organization called the Institute of Image Electronics Engineers of Japan, and they were having their 25th anniversary in 1997. So a professor at Nagano Institute of Technology decided to build a pair of Bain fax machines using nothing but the 1843 patent as the guide. And he did that, and you can watch it making a complex Japanese character as the thing goes back and forth. So he came up with scanning, but he didn't have any way of converting light into electricity. Now, that was actually first discovered in 1839, even before his system. Edmund Becquerel discovered a photoelectric effect. And even though Becquerel published it in major journals, everyone said, okay, that's interesting. So you get voltage when there's electricity, and when there's light, but nobody did anything with it. Well, Bain's fax system was commercialized in 1865, starting in France. You could send faxes for money between different cities. And so there were many, many fax systems that were available by the 1870s, but there still wasn't this light to electricity conversion. So something else important happened. In 1858, the first transatlantic telegraph cable opened. And the first message that was transmitted from Queen Victoria to the President of the United States took 16 hours to transmit. And the reply took something like 67 minutes. The reason it was 16 hours going in one direction, they weren't expecting the message. So it took a lot of retransmitting before they knew what was going on. So 67 minutes in the other direction, still pretty long for a short message. So one of the engineers, who had been a surgeon and became an electrician and styled himself Wild Man Whitehouse, said, I know what the problem is. There's not enough voltage. Let's increase it to 2,000 volts. So they sent 2,000 volts into the cable, and that was the end of the first transatlantic telegraph cable. Now, in his defense, recent research shows that maybe there were defects of manufacture and it wasn't his voltage that was the problem. But whatever it was, that cable died, and so when they put in the second transatlantic telegraph cable, they wanted to really, really be careful. And so a guy who was in charge of the system, Willoughby Smith, designed a bridge that could measure the health of the cable at all times. But the cable is really long. It's crossing the Atlantic, so it's got a pretty high resistance. So he had to have something with high resistance to use in his bridge. and somebody said, why don't you use selenium? So he said, okay. So he used crystalline selenium, and it seemed to work fine. And then one day, his assistant, Joseph May, is doing something, and a cloud passes overhead, and all the readings change. And the cloud goes away, and the readings change again. And he goes, hey, boss, I think I see something here. So that was 1872. So 1873, Willoughby Smith had completed doing experiments which proved that selenium was photoconductive. So he brings it to the Society of Telegraph Engineers. He announces it. There's tremendous publicity. It appears in Nature, Scientific American, and so on. A lot of people say, no, it's not true. So he defends it. Other people do experiments. Their experiments confirm what he did. And one of the people who does experiments is Werner Siemens in Germany, of the Siemens company. And he does the best experiments and proves what you should do to make the selenium be most photosensitive and so on. And his brother, William Siemens, in London in 1876 says, okay, I will give a lecture to the Royal Institution on what we've been doing. And he gives this lecture, and towards the end of the lecture, he pulls out this big round thing that looks like an eye. In fact, it's got eyelids on it. And it's basically a 1-pixel camera. And the only thing it can do is, if you shine enough light in it, the eyelid will close. So it's like it's being fatigued from too much light or something. And everybody goes, okay, that's cool. But Scientific American goes, oh, we are sorry to report that he has not made an eye that will bring vision to the blind, but maybe he has begun the germ of the idea. Well, 2 of the television inventors in 1877 said, we read that Scientific American article, we knew about the scanning from Bain, we now know about the light to electricity, we decided to invent television. And so that's where television came from. Thanks.